Okay, so this section we're going to start talking about regular polygons and their areas. So a regular polygon, remember, is just a polygon with congruent sides and congruent angles. So there's an example here with a pentagon. So all the sides are congruent, all the angles are congruent. The center of the regular polygon is just what you would think. It's the middle point. It's actually the center of the circumscribed circle. So circumscribed means it's around the shape. So center of circumscribed circle. And the radius is the radius of that circle, which is also the segment from the center to a vertex. So F to E, for example, would be a radius. The apothem is the distance from the center to a side. So FG would be an example of the apothem. And then the central angle of a polygon is formed by two radii drawn to consecutive vertices. And you could find the measure, because it's a regular shape, by just taking 360 divided by however many sides you have in your shape, divided by the sides. So in this case it's 360 divided by 5 for the example of the pentagon. So 72. Okay, so if we look at our shape and we want to find the area, we've divided it up into 5 congruent triangles already. So if we wanted to find the area of each triangle, we would do 1/2 base times height. Okay, so if we call the base of each triangle S for side of the pentagon, and then we call the height of each triangle A for apothem, since it is the apothem, then the formula for one triangle in this pentagon becomes 1/2 apothem times side length, A times S. So the total area would be that triangle multiplied by however many you have. So the general, for a general regular shape, it would just be however many sides you have, that's how many triangles you'd have. So we can just say n for sides. For our example, it would be 5. Okay, so if we kind of extend that a little bit further and think about what S times n really means, if I do the side length times however many sides I have, what is that? So that's just the perimeter, right? So I can really replace in that formula the S and N with a P for perimeter. So the formula becomes area equals 1/2 apothem times the perimeter. Remember, this is just for regular shapes. This is going to work out. So if we try an example here, we're given a radius of a hexagon, of a regular hexagon, is 10. So we need to find the apothem and we need to find the side length so that we can find the perimeter. So if we think about the central angle, we can use central angles to help us find side lengths. So since it's a hexagon, the central angle is going to be 360 divided by 6. So there are 6 central angles, so that gets us 60 degrees. The apothem drawn down divides that central angle into 2 congruent angles, so each would be 30, which means we have a 30, 60, 90 triangle. So to go from hypotenuse to short leg, we cut it in half. To go from short leg to long leg, which happens to be the apothem, we multiply by √3. So when I do my formula for area, I get, so it's 1/2 apothem times perimeter. The apothem we just said was 5√3 for my special right triangle, and the perimeter would be the 10, which is the side length, times 6, so 60. So let's see, we have 30 times 5, so 150√3 for the total area of that shape. Okay, and then I'm going to skip to the last problem. So for this problem, it says find the area of a regular pentagon inscribed in a circle with radius 8. So regular pentagon The inscribed in the circle part really is just to help you understand that the radius is this distance from the center to the vertex. So you can draw the circle if you want, you don't have to. So just like before, we have to have the apothem and the perimeter. So what we can do is start with the central angle again. So 360 divided by 5, since it's a pentagon, 72. And just like before, the apothem is going to split that 72 up into two congruent angles. So what I'm left with, if I take this triangle out, would be two right triangles, so that it has the top angle of 36 degrees and then the hypotenuse is 8. So I would have to actually do some trig on this one. So I can do, let's call this X and I'll call this A for apothem, because the height of this triangle would be the apothem in your shape. So I can do the sine of 36 will equal opposite over hypotenuse, and then multiplying, let's see, 8 times the sine of 36 together, we get 4.7 for X, which, remember, that's just this piece, so it's just half of a side, so the whole side is then going to be 4.7 times 2, so we got 9.4 for the entire side length. Okay, so next we need to find the apothem. So you can either use trig or Pythagorean theorem now that we have two sides. So I'm going to go ahead and use Pythagorean theorem, which means that the a squared, the apothem squared, is going to equal the hypotenuse squared minus the side squared. Remember, the side was just the 4.7. Okay, so if I do 64 minus 4.7 squared, that gives me 41.91, and then I'm going to take the square root of that, which is 6.47. For the apothem. So now I have everything I need, so I can plug it into my formula. Again, 1/2 apothem times perimeter, so 1/2 apothem, which we just found was 6.47, and then the perimeter is going to be the side length times 5 sides, since it is a pentagon. So what's the 9.4 times 5? That gets us 47 for the perimeter. Okay. So then if we multiply all of that together, we get, let's see, 47 times 6.47 divided by 2, 152.045. And that is it. So for homework, I want you to do section 11.4 and just do problems 11 through 21.